Hey, it's Poisson Variance, your VTuber, math lover, gamer, and nonsense enjoyer, and today we're going to be talking about one of the most misunderstood pieces of statistics, and that is p-values. Before we get into p-values, we have to understand two things: the null hypothesis and the alternative hypothesis. The null hypothesis is like a default statement about a parameter of a population, sort of the default that we assume to be true. For example, imagine you have two balls of varying sizes. The null hypothesis might say that the size of the ball has no bearing on the weight of the ball. Now let's look at an alternative hypothesis. An alternative hypothesis has to contradict the null hypothesis. So, the contradiction could say, if one ball is larger than another ball, then that ball will have greater weight. Before we get into the definition of the p-value itself, we're going to need another definition. That's called a test statistic. Think of it as a function that takes in pieces of the sample data, and then it gives out a value. I also want to quickly mention something that the p-value is not. A common misunderstanding is the assumption that the p-value is the probability that the null hypothesis is true. This is not the case. What the p-value actually is this. So first, assume that the null hypothesis is true. Then, the p-value is the probability that using our previously mentioned test statistic, that it will produce an answer that contradicts the null hypothesis. But for whether or not it contradicts the null hypothesis, we need one more term, and that is a significance level. A significance level is an alpha that we get to choose to compare the p-value against. If p is greater than alpha, then the null hypothesis will not be rejected. If p is less than or equal to alpha, then the null hypothesis will be rejected in favor of the alternative hypothesis. That was a lot, and it doesn't exactly roll off the tongue super well, so I get being confused about it. So here are some key points we have to remember. First, the p-value is a probability. Second, the p-value assumes that the null hypothesis is true. Third, to determine the p-value at all, we have to figure out what values of the test statistic contradict the null hypothesis. Fourth, the smaller the p-value is, the stronger the evidence is against the null hypothesis in favor of the alternative hypothesis. And fifth, and the most common mistake, the p-value is not the probability that the null hypothesis is true or false. There's definitely more to say about this, but I think that's best saved for another time. But regardless, I hope to some extent that helped clarify what exactly a p-value is. Anyways, I've been Poisson Variance, your VTuber, math lover, gamer, and nonsense enjoyer. Thanks for watching, and bye-bye!